All right, in this lesson, this is actually 1.6, selecting methods for solving combinations and permutations. There are no notes for this lesson. So what I want you to do instead is get out your 1.5 and your 1.4 notes. What we're going to do today is instead of give you new notes, we're going to talk through how to identify whether or not you have a permutation or a combination, and that will help you determine how to solve it. So we're actually going to start with 1.5, the permutations, because these are a little bit easier to identify than combinations. Okay, so if I'm going back through my 1.5 notes that I've already finished, I know in each problem I've already told you that it's a permutation, but let's pretend for a minute that you didn't know that. We're going to highlight some keywords and phrases throughout the document that let us know that this is a permutation question, and that will determine how we solve these problems. Okay, so in this first one, all right, uh, how many four-digit numbers with distinct digits exist in mathematics? This word distinct, another word that you'll commonly see is unique. Those are some keywords that let you know the order of the numbers matters. And remember, if order matters, this is a permutation. Normally, ones with numbers are always going to be a permutation because no two numbers in math are the same. That won't always be true, but most of the time that is a pretty safe bet. Okay, let's look at this next one. In problem 2, it says a student council with 10 members wants to elect a president, vice president, secretary, and a treasurer. Okay, so this is a really common permutation problem. And I'm going to go ahead and highlight this phrase right here. And I know we've actually already underlined part of that phrase, but now to point it out to you more directly, there are defined roles in this problem. Okay, you're not just selecting 4 people at random, you're selecting 4 people to fill very specific roles. Okay, if there are defined roles in a problem, president, vice president, secretary, treasurer, some sort of title that you're giving to somebody, then the person that you hire for that title definitely matters. All right, so in this case, it's a permutation. I can't just pick 4 random people. I have to think through who is going to fill these roles well. Okay, when I look at problem number 3, it says you remember that the first 2 digits of a 4-digit combination are 7 and 3, and that no numbers repeat themselves. How many possible ways are there to guess the 2 remaining digits? Now, this one is a little tricky because you see the word combination. Okay, and you might think, well, hey, I'm going to solve this with a combination. That's actually really misleading, and I'm not sure why. Um, like if you think of a combination lock, something that looks like this, a little lock on your locker, um, those should not be called combination locks. Technically, they should be called permutation locks because the order in which you put the numbers in matters, all right? So anytime we're dealing with passcodes or combinations, we're actually talking about permutations. Right? Any sort of passphrase, anything in which the order of the symbols that you put into it determines whether or not you'll open it. Okay, let's look at number 4. Suppose there are 4 physics textbooks, 6 math textbooks, and 2 chemistry textbooks that need to be arranged on a single shelf. How many possible ways can the books be arranged if all the same subjects need to be next to each other? Okay, this is another very common permutation problem, and I'm going to highlight 2 keywords here. First, we have the word arranged, and then it pops up again down here. All right, so anytime that we are arranging something, if you are organizing and arranging something, let's say alphabetically, for example, then the order matters. All right, so anytime you see the word arrange, we're talking about a permutation. In this case, I would not just go randomly putting books on the shelf. I have to group all the physics ones together, all the math ones together, and all the chemistry ones together. All right? And last, problem number 5. It says 8 people are seated at a dinner table for a political fundraiser. You planned the seating arrangement. What is the probability that the vice president and the president end up seated next to each other? Okay, now a couple different things going on here. First, we see that we have, oops, wrong tool. First, we see that we have very clearly defined roles. There's a vice president and a president. So that's my first clue that I know, okay, this is a permutation. The next clue that we have is a seating arrangement. Okay, seating arrangements are almost always permutations because you can only put one person in one chair. All right. And the second you start arranging people into different chairs, now all of a sudden, which chair they sit in matters. All right. So there's a couple different things going on. All right. We have defined roles. And we have a seating arrangement. And remember, anytime we see the word arrange, that also tells us that this is a permutation. Okay, so to identify a permutation, we're looking for some key phrases or some key things happening. So maybe at the bottom of my notes on the back, um, I'm just going to jot down some quick notes. So to identify permutation problems, we're looking for a couple things. All right. Remember, order matters. This is your key for determining whether or not you are dealing with a permutation problem. So a lot of times it's just a matter of logically thinking through, does the order of this situation matter or not? And if it does, it's a permutation. So let's go back through the list and talk about what key phrases we can identify. So remember, anytime you see the word distinct or unique, okay, this tells you that the order of something must be distinct or unique. Um, for example, 1, 2, 3 is not the same as 2, 3, 1. This tells you it's a permutation. So that's the first thing. Next thing, we have defined roles. President, vice president, secretary, treasurer, manager, class leader, whatever. If there are defined roles that we are assigning to people, then that's a permutation. Okay, we also talked about if you see the word arrange. Okay, the word arrange tells you that you are putting things into order. So order matters. Let's see, whatever. Anytime we're talking about locks, uh, oops, there we go. Anytime we're talking about locks, passcodes, combinations, any sort of passkey, this is also a scenario when order matters, and you'll be using a permutation. Anytime we're talking about seeding, okay, this is a type of arrangement. And so usually it'll say seeding or seeding arrangement. In that case, we're talking about a permutation. And then let me do a quick scan, see if I forgot any. No, I think that's all of them. Now, there's a couple, actually, I think there's just, no, there are a couple that I can think of that are not on this list um, because they weren't in the notes. So another way is uh, people lining up for something. So this is also a special type of arrangement. It matters who's first in line. It matters who's second in line. It matters who's third in line. So that's another case where this will be a permutation. And then the last one that I can think of off the top of my head is also competitions. So what do I mean by competitions? This is when you're awarding somebody first place, second place, third place, etc. So any type of like sports tournament or competitive bracket, any sort of thing like that, that's also going to be a permutation because there can only be one person in first place, and that definitely matters. Okay, now these are not the only 7 examples that exist out there. I'm sure there are some others, but these are just a good start for you guys to start to identify whether or not you're working with a permutation or a combination. Okay, now what I'm going to do um, is I'm going to pause the video. I'm going to switch over to my 1.4 notes, and we're going to look at combinations. And combinations are a little bit harder to tell because you're not looking for specific phrases. You're just looking to see that none of these phrases exist. Okay, so let me go ahead and switch over those notes. Okay, now when I'm looking at combinations, all right, again, we're not necessarily looking for any key phrases. We're just looking to see that there's nothing that says it'll be a permutation. That's why these are a little bit trickier to identify. So that's why we're doing these second. Okay, so let's do the same thing. Let's go through each problem. All right. It says in the first one, a public committee of 3 people is to be elected from a group of 2 male candidates and 3 female candidates. What is the probability that the committee will consist of 1 man and 2 women? This is another very common combination problem. There actually is a keyword here, uh, committee. So anytime there's a committee with no defined roles, it does not say chairman, it does not say senator, president, whatever. Anytime there's just a general committee with no roles, it does not matter the order in which you select people. So this is a combination problem. Okay, let's look at the next one. It says a broadcasting director is scheduling commercials for a sponsor. There are 6 time slots available to air commercials. How many ways can the commercials be scheduled? So in this one, again, um, not necessarily a key word here for combinations, but time slots is what lets me know um, that this is a combination, and the fact that it's a commercial. So it does not matter what order commercials run in, as long as you get your commercial out there on TV at some point. That's how it lets me know that this is a combination. So anything like that, when you're scheduling a time for something and you have available slots, and it doesn't matter what slot you pick, just as long as you schedule it, that's also letting me know it's a combination. Okay, when we look at problem 3, what is the probability that a football team that plays 10 games this season will have 6 wins and 4 losses? Solve this problem 2 different ways. Okay, now, I said competitions in sports are normally permutations, But notice for this one, it does not say that I have to win the first 3 games or that I have to lose the sixth, seventh, and eighth game. It does not tell me the specifics of the wins and losses. So I'm going to say no specifics given. Oops, sorry about that. For the order of wins and losses. So because there's no specifics given on the order of wins and losses, then it doesn't matter. It doesn't matter if I win the first 6. It doesn't matter if I win the middle 6. So in that case, it's a combination, not a permutation. Okay, and then the last one. Uh, Anytime we are asking ourselves how many different ways can I pick something, how many ways? Okay, anytime I'm asking something like that, another way to phrase that is how many different possible combinations are there? And yes, I know combination is a little misleading because if we're talking about unlocking a cell phone, that combination is actually a permutation. But if we're talking about um, ordering toppings for a pizza at a restaurant, or packing, in this case, packing different combinations of outfits, or choosing between snacks at the coffee cart. When we're doing something like that, that kind of combination is actually a combination. So there's no real notes I want to jot down here. I just want you to realize that in all of these problems, all you have to do is read through it and ask yourself, does the order of this situation matter? And if it doesn't, it's a combination. If it does, and you see some of those key phrases like in the 1.5 notes, then you probably have a permutation. So I know this is a little bit harder. It's a little bit more logical and abstract to wrap your head around, but I want you guys to be thinking through this as you continue into lesson 1.6.